recording. Okay, so we are entering chapter 3 of S2. Chapter 3, S2. Okay, so S2, this is continuous distribution, continuous random variable. Okay, so from S1, okay, we did about discrete distribution. Okay, we did about discrete distribution. So if for example of the dice, okay, we have the form of 1, 2, 3, 4, 5, 6. Okay, and then we have the probability if it's a fair dice or each of them are actually at the same value, 1/6. Okay, then we say that this is a probability, and this is the x possible x value. Okay, this is how it looks like when we're dealing with a discrete form. Now for S2, we are talking about continuous distribution. Okay, continuous distribution. Right now, what you have is fx, where the shape, it could be in any shape that we want. Okay, so and this will be the possible x value. Okay, so maybe a to b of x, and this fx here we call it PDF. Okay, PDF here means probability density function. Okay, so characteristic of continuous distribution. Okay, the characteristic of continuous distribution, of course, your x must be a continuous variable. Okay, continuous variable such as weight. Okay, is a continuous variable such as length. They are continuous variable. Okay, then total area under the graph have to be equals to 1. Area equals to 1. Okay, then you have a certain interval. Okay, a certain interval of x, within interval of x. So in this case, x is in between of a to b. Okay, then we have the form. What else do we have? Okay, x cannot be the probability cannot be a negative number. Okay, probability n, probability graph cannot be negative. Okay, cannot be negative. So over here, usually we write PDF as a piecewise functions. Okay, a function that written in pieces. Okay, so for example, for this shape that we have, okay, so let's say 1, 2, 4. Okay, I have the k value here. Okay, this is my small letter f, this is my x. Okay, okay, 1 over this one I change it into 1/3 something 6. It's 1/a. This is something times by 3, 1/3, 1/3, 1/6. 2/3. Okay, let's say I have a 2/3 here. Okay, so first of all, if this is 2/3, then we can see the size of the area. If we fill the area triangle, you have a size of 3 here. Then this is 2/3. Then by using half times base times height, we have 1 over 2 times 3 times 2 over 3. So you can see that it's equals to 1. Okay, therefore you have a 2 over 3 there. And when we write our function written as a piecewise function, we'll write it in this way. So we will write as the function of x will be this one will be 2 over 9 x, okay, minus what number, what value? So I need to in the straight line equation form, 2 over 9 y equals to mx plus c. So I have this is a 0, this is a 2 over 9, this is a 1, so equals minus 2 over 9. Then 0. Okay, 2 over 9x minus 2 over 9. X is in between of 1 to 4 and otherwise. Okay, what I'm trying to tell you is usually your PDF will be written as a piecewise functions like this. Okay, will be given in this form. This is called a piecewise function, where it's actually representing in the form of graph. Okay, then also can be written in the form of pieces. Okay, 0 for any other value of x that is lesser than 1 and greater than 4. Okay, so you have a questions that actually look like that. So after that, okay, for the graph, it can be more than one shape. Okay, it can be more than one shape. So let me try to find some questions that there's a combination of shapes. Okay, combinations of shapes. Let's see. Wait for a while. Very fast. Okay, so maybe you have a question that look like this. Okay, so this is actually more than one part. Okay, so as I say, usually the question can be written as a piecewise function. So this one is from 0 to 3, 3 to 4, and 0 otherwise. Then sketch. Then I ask you to sketch. The very first thing that they ask you to do is sketching. So we do the sketching. So 0 to 3, okay, 3 to 4. So 1, 2, 3, then 4. Okay, so this is 1 over 6. So when 0 is 0, when 3 it become 1 over 2. So it become up to 1 over 2. Okay, 1 over 2. Then you have a 3 to 4. So when 3 you put it inside. Okay, so 2 minus 3 over 2 is still 1 over 2. Then the 4 you put it inside becomes 0. Now it becomes like this, 0. Okay, so this is your fx, this is your x. So this is how your question will look like. So in the end, okay, technically it will look like this. Why is it flat over here? Because of the 0 otherwise. Any questions? So far so good.
All good.
Okay. So as you can see, we just draw the graph according to the pieces given by the shape. Okay. So you see that the next part they can ask about different types of things over here, right? So we will worry about that later. Okay, so this is the very first thing that you need to know, which is called a PDF. Okay, which is called a PDF. So same like your other questions, okay, you are required to, what do you need to know? You need to know what? You need to know mean, median, mode. Okay, Q1, Q2 is median. Q3, you need to know IQR. You need to know variance. Okay, you need to know variance standard deviation over here. Okay, you need to know skewness. Okay, just like how you did in your S1. Okay, these are all the common things that we always ask in the questions. Okay, so you are required to know how to actually answer these kind of questions. So let's see. Let's say I'm using this shape that I just created just now. So okay, fx equals 2 over 9x minus 2 over 9. So 1 to 4. Okay, so I'm using this example. Fx equals 2 over 9x minus 2 over 9. Okay, then this is from 1 to 4. Okay, 1 to 0. Then this is 0 otherwise. Okay, so 2, 4, 8. Then we also have the shape of the graph that actually provide us this information. 4 and this is 2 over 3. Yeah. Okay. So far this is what we know. Okay. From this graph, what can we say about mode? Anyone?
There is no move.
There is a mode.
Oh, is it 0?
No. Mode
The
is the
mode
value
1.
of x. The value of x that provide the highest probability.
Is it 1?
Hmm? It's not
Is it
1.
1?
It's not. It's not 1. Remember in chapter 1, we learned about mode. Mode is the value of x with the highest frequency, right? Over here is the highest probability. That means it's the highest point of the graph. The mode is
4.
1.
the mode is
1.
4. Okay, the mode that we want to calculate is 4. So how about median? Median is the value of x that gives you the probability half, isn't it? X value that split area into half. Don't talk about don't look at the statistic point of view first. Just look at the pure math point of view. How can we tackle these questions?
Is it
Wait, by area?
2.5?
Can it sorry?
Is the median 2.5?
2.5. Okay, you're suggesting 2.5. Let's see, So I have 1 here, I have 4 here, then you say that 2.5 is here. So 2.5, that means this coordinate is 2.5. I put it inside. Okay, 2 times 2.5 minus 2, I have 3, so 3 over 9. So this is 1 over 3 here, the height of 1 over 3. So this one is the length of 1.5. So this area 1 over 2 times 1.5 times 1 over 3. So 2 times 1.5 times divided by 3. I have hey, what did I do wrong? 2 Oh, sorry. I go and multiply by the 2. So 1.5 divided by 3 divided by 2. I have a 1 over 4. 1.5 divided by 2 divided by 3. I have 1 over 4. So is it half? It's not a half, isn't it? Therefore, 2.5 is not the answer.
Do we have to use integration?
If it's a curve, yes. But this is a straight line. Of course, you can use integration to solve or anything because it's a continuous graph. Nothing wrong with that. But since this one is a straight line, it's actually an easier approach. You can have more understanding approach. By the way, Hillary, how do you actually come up with 2.5 previously?
Oh, I took in between 1 and 4.
In between more than 4? 1 and 4, 2.5. Oh, okay. So you will see that even that you do that, okay, 2.5, you'll see that the size of the area doesn't fit, it doesn't fit 1 over 2. Therefore, it's wrong. Alex, since you talk about integration, maybe you want to propose how are you going to start the writing?
I mean, basically, you calculate the whole area under the whole area of the triangle.
Mm-hmm.
So that is 4 minus 1 times 2 over 3.
4 minus 4 minus
4 minus 1 times 2 over 3 times 1 over 2.
Oh,
So the
you change your approach. Okay.
yeah,
But the area have to goes to half. But so you have whatever the answer that you get, you'll get an area equals to half.
yep.
Okay, what number do you get?
Oh, I shall try now.
Please understand the question they're asking here is not statistics, you know. They are all logical thinking. Just using logical thinking to actually figure out the answer. Because we didn't use any advanced technique. It's all purely understanding here. The objective is just to find the value of x that actually split the area into half. 0.5. Find the value of x that actually give us the area 0.5. That's all. Nothing special here. It's all purely logical thinking. If as long as you are able to tell me the logical thinking working, you score the marks. That's the analyzing skill that we want from students. Anyone got any other approach? Since Alex still
Oh,
working,
wait. Can we use the methods of similar triangle?
you don't get the half, isn't it, Alex?
I can if I do all the algebra, but I'm just thinking, being lazy.
Teacher, I think I got it.
Okay, tell me your approach.
So I go and times 1 over square root 2. Like the 4 minus 1 is 3, so then 3 times 1 over square root 2, then and then I sub it in. And then, the area is 1 over 2.
You realize that your 1 over square root 2 actually come from nowhere, isn't it?
Kind of.
Okay, how do you expect your classmate able to know that it's 1 is square root 2?
Because I thought that, because what Hillary did was she found half, right? Half
Yes.
of the length.
Mm.
But then if it's half of the length, then the y part is also half.
Mm.
So then you times 2 together, then you get 1/4. But if you take 1/√2 of each, then you get 1/2.
Okay. Yes, it's kind of true. Okay. The easiest approach is to find the area that equals to half by looking at the length. So this one, the length here is m minus 1, where the medium equals to the medium equals to m. Okay, this is m this is m, this is 1, therefore it's m minus 1. Then for your height, you have 2/9 m minus 2/9. So you have a 1/2 times by m minus 1 times by 2/9 m minus 2/9 equals to 1/2. So 1/2 cancel off, 2/9 all cancel off, then you have a m minus 1 square equals to 1. So you have m squared. Hey, did I calculate them correctly? 1/2, okay. M squared minus 2m plus 1 equals to 1. Okay. M equals to 0, m equals to 2. Okay, it suggests that m equals to 2. Let's see. Suggested that the m answer is, the medium answer is 2. So since here it says suggested is 2, cannot be. I do a wrong calculation somewhere. Where did I wrong? Where did I make mistakes? Where did I make mistakes? 1/2 times base times height. Height is m, 2/9 m minus 2/9. Oh, sorry, my mistake. So I have a 1/2, 2/9, then m minus 1 square equals to 1/2. So m minus 1 square equals to 9/2. 9/2. So I have a m equals to square root of square 3/square root 2 plus 1. 3/square root 2 plus 1. 3 point something. So let's see whether it's correct or not. So if m equals to 3/square root 2 plus 1, so the bottom here I have the length of 3/square root 2. Then the height here will be minus 1 times 2 divided by 9. So square root 2/3. Okay, the area equals to 1/2 times base times height. So it's 1/2. So this is the answer. 3/square root 2 plus 1 is the answer. Earlier I make mistakes because I cancel off the 2/9. So what do you think? Of course, this working here doesn't look so good. But what if we do integration? Integration from 1 to m of 2/9x minus 2/9 dx equals to 1/2. So I have a 2/9 of x squared over 2 minus x of m to 1 equals to 1/2. So I have a m squared over 2 minus m minus 1 over 2 plus 1 equals to 9 over 4. So I have a m squared over 2 minus m. Okay, so this one minus 0.5 plus 1 minus 9 over 4. So I have a negative 7 over 4. Okay, multiply everything by 4. So 2m squared minus 4m minus 7 equals 0. So I press calculator. 2 equal minus 4 equal minus 7 equal. I have a m equals to 2 plus 3 square root 2 over 2. Okay, 2 minus 3 square root 2 over 2. Okay, same answer. This one rejected. Same answer. So by doing integration, you will see that it's much more straightforward. Okay or not?
Wait, we can use methods of similar triangles too, right?
You can, but do you do it correctly?
Uh,
The similar triangle,
mm.
you can actually do it, but just now you didn't do it right because you didn't consider one dimension and two dimension. One is length, one is area.
Yeah, that's what you have to consider. So they raise in different proportions. Then you
Yes,
have to,
exactly.
yeah.
But of course, you can always ask yourself, is your approach will be more straightforward than these two or not? Will you actually able to solve the question in 1 hour 15 minutes? Understand, Alex?
Yep.
Others? You can tell me what do you think? Okay or not? Survivor or not? Surviving or not? Okay. So this is mode, this is median. So what about the mean? Okay, E of x from S1. So we do E of x equals to summation of all x. So x times px. So for S2, so E of x will be integration for all x. So x of fx dx. Okay, so this will be in the form of integration. So for this question, so expected of x will be integrate from 1 to 4 of x of 2 over 9 x minus 2 over 9 dx. Of course, with the help of calculator, you can get the answer immediately. So I have a 2x squared minus 2x over 9 from 1 to 4. I have a 3 as answer.
For the mean, we just use so you just use the equation and then you get the mean. This equation x f(x) dx, then you get the answer.
Yes, yes.
Um,
It's the formula. Mean.
right.
From summation form change to the integration form. Because of continuous variable. Okay with this? So we have mode equals to 4. Okay, we have median equals to 3 over square root 2 plus 1. So let me write out the number. 3 over square root 2 plus 1. So 3 divided by square root 2 plus 1 is 3.12. And you have a mean equals to 3. What conclusion can we make from here based on S1, chapter 1? What conclusion can we make by looking at this 3 figure? Anyone remember from S1?
Is it negatively skewed?
Very good. Okay, so you are able, by looking at this, you should be able to explain about its skewness. Okay, you should be able to explain about its skewness. So we have a mode, median, mean. Okay, then what about Q1 and Q3? Okay, Q1, luckily, just now Hilary already mentioned it. So I managed to find the Q1 equals to 2.5. Okay, so it happened to be 1 over 4, but this is just happened to be, isn't it? So what if we want to solve it in the proper way? How do we actually find Q1 and Q3? Anyone? How do we find Q1 and Q3? Although that we already know the answer for Q1 is 2.5, but how do we actually do it in the proper way?
Can we use the same method, but you find the area is 1 over 4 and 3 over 4?
1 over 4 and 3 over 4. Yes, we can actually use a 1 over 4 and 3 over 4. Okay. So what method are you proposing?
Either the integration one or the complicated Anika one.
So not so complicated, it's just the value is not nice, that's all. Okay. So if you, let's say you're using let's say we want to look at Q1. Okay, so you have a triangle with a Q1 minus 1. So we have a 2 over 9 Q1 minus 2 over 9. Then we have a 1 over 2 of Q1 minus 1. 2 over 9 Q1 minus 2 over 9 equals to 1 over 4. So what we need to do is just solve them properly. 1 over 2, 2 over 9, Q1 minus 1 square equals to 1 over 4. So I have a 2 cancel off. I have a Q1 minus 1 equals to 9 over 4. Okay, square this one square. So Q1 minus 1 equals to 3 over 2. So Q1 equals to 2.5. This is what. Once you write them properly, it's not that difficult, isn't it? It's not that complex, isn't it? Okay, or you can actually do it in the integration way. Integration way will be 1 to Q1 of 2 over 9 x minus 2 over 9 equals to 1 over 4. Then you have to solve your integration accordingly. Of course, you will get x equals 2 over 9, 2.5. Okay, now try to find Q3. Guys, you can take your turn to find Q3. What answer do you get? Do you know how to do the calculation, guys? Am I lost you or anything? Yeah, you guys still there?
3.59,
Hmm?
3.6, 3.60 for Q3.
Again, your value? I can't hear.
3.60.
3.60.
I got that for Q3.
Okay, we have to, let's see whether do we get it correct or not. This one, times 2. So square root plus 1. So Adam, you got 3.60. Okay, that's the correct answer. Others? Hello? The rest? Are you still there?
Yep.
Did you manage to get the number or not?
Yes, of course.
Okay. So what if I want to explain skewness from these two values? What should I do? What if I want to explain skewness from the value? I have Q1, Q2, Q3 values that look like this. Q1 equals to 2.5. Q2 equals to 3.16. 3.16, 3.12. 3.12, my mistake. Okay. And Q3 equals to 3.60. How should I explain the skewness from here?
Find Q3 minus Q2 and Q2 minus Q1.
Q3 minus Q2 and Q2 minus Q1. Okay, what is the number that I get? 6 minus 3.12, you have this one 0.48. 3.12 minus 2.5, I have a 0.62. Then how do we make our conclusion?
Since Q2 minus Q1 is larger than Q3 minus Q2, therefore it is negatively skewed.
Q2 minus Q1 is larger than Q3 minus Q2, hence is a negatively skewed. Okay. Looks like over here you will see today you actually have a lot of revision. Okay, that actually require you to remember knowledge from S1. Okay, then from here, okay, so standard deviation and variance. Okay, final thing. We still have the same questions. Okay, we want to calculate variance. Okay, the variance formula is still following e of x squared minus e of x the whole thing square. This is still true. Okay, the problem is the expected of x squared. The expected of x squared will be in the integration form, or x for x squared of fx dx. So if you write them out, we have 1 to 4 x squared is 2 over 9x minus 2 over 9 dx. Okay, press calculator, 2x cubed minus 2x squared over 9 from 1 to 4. I have a 9.5. Then from your variance here, it goes to 9.5 minus the mean that we have earlier is, where is it, the value? 3, okay, 3 squared. So the answer is 0.5. And the standard deviation, it will be square root of 0.5. Okay, so 1 over square root 2 as answer. 0.7071. Are you okay?
Yeah.
So today your work, your homework is to find this. Okay. You are required to find mean, median, mode, Q1, Q3, skewness, okay, variance. So we will look at this tomorrow. Okay. Ken?
Yes.
Yes.
Okay.